This is the second part of the chemical changes topic in the AQA GCSE chemistry topic. It counts for dual award and triple award, so all students taking AQA chemistry would benefit from going through this work. Going to recommend you pause as you go and have a go at the activities for yourselves. So in this particular video, we're going to build on the work we did with exothermic and endothermic reactions last time, and we're going to look at some practical applications of them. A reminder, in exothermic reactions, heat energy is released to the surroundings, so the temperature of the surroundings goes up, and the reverse is true for endothermic. So let's take a look at some examples. Do we think that these are exo or endo? And again, it's really important to get this clear in your mind. If something causes a temperature increase, it's exo. So if we burn a fuel, that's always an exothermic reaction. It always gets hotter around it. So if that's true for burning coal, it's also true for hand warmers. You will be familiar with hand warmers. You might have single-use ones with activated charcoal, or you might have a reusable one that we're going to talk about a little more later on. And finally, cold packs for injuries. Anyone that's ever injured an ankle or anything really might have been given an ice pack, and that brings the temperature down. So that's very clearly an endothermic reaction. So let's take a look at a couple of examples. We've got hand warmers here. Now, it might be that you have a single-use hand warmer. That's iron filings and iron oxide. And when you open those up, they will react together, they will generate heat, and you can use those to warm your hands on a cold day. But once that reaction has happened, you can't use them again. Reusable ones come with a gel that you have to boil in water after they've been used. Now, they work by taking a salt called sodium ethanoate, supersaturated, and then there's a small disc inside that you click, and what that will actually do is cause the crystallization of that supersaturated salt. And that's an exothermic reaction, so that will generate heat energy, and that's why it warms up. When you put it in boiling water, you're redissolving that salt, and that's why the temperature goes back down and it becomes a supersaturated liquid again. We've already spoken a little bit about cold compresses. In these, it generally tends to be ammonium nitrate and water, and they're separate within the pack. But when you squeeze it, they mix together, and that's a very endothermic reaction. It brings the temperature down, which can be very useful if you're injured. So, a few questions for you to think about based on what you've seen. So two uses of endothermic reactions. Well, one of them is ice packs that we've spoken about, but it can also be a self-cooling can. It's possible to buy cans that don't need to be refrigerated with iced coffee, for example. And it's the same principle. There will be an endothermic reaction taking place in the surrounding material of that can to cool the liquid down inside. What chemical reaction takes place in cold packs? Well, I'm going to look at the reusable ones, and we've already discussed ammonium nitrate reacts with water. Now we squeeze the pack to mix those together so they can react, and it's an endothermic reaction, which causes the temperature to decrease. Moving on to number 3, what's the advantage of having a cold pack in a first aid kit rather than using ice? Well, if you had ice in there, you would need to keep it as ice. So you'd need to keep it below 0 degrees C. And that's going to mean you would need an energy source. With these, you don't need the energy source. And there's also the risk that if you're just putting ice on somebody, that it might melt, it might leak. It's not going to be as convenient. This is all taking place inside a sealed plastic bag. And then let's take a look at number 4. Describe the chemical reaction taking place in a reusable hand warmer. And again, we're going to take a look at the reusable form here, because that's what it says. And we're using supersaturated sodium ethanoate, CH3COONA. Not hugely important that you remember that formula, but you need to know that this is something that will essentially, when you click the metal disc inside, tiny particles scrape off that. And so crystals start to form. the crystals come out of solution. And that's an exothermic process. So that will release heat energy. And as I've already said earlier in the video, I can then boil that reusable hand warmer, and that will then take the crystals back into solution, ready to use again. So that's just a couple of examples. That takes us to the end of this video. Thank you for listening, and goodbye.